All right, this is 7.1.1. We're going to be simplifying rational expressions. So we're going to understand the restrictions of a rational expression and simplify a rational expression. Now, you've simplified fractions before. Those are rational expressions. But one thing that we kind of have to remove is this shortcut that's been taught to us, right? This 20 over 60, how does that simplify? Well, we're used to thinking to ourselves, oh, well, whatever it is, you just divide the top and the bottom by it, and then you're going to get your answer. But the reality is that there are factors within 20 and within 60, and it's those common factors that reduce. So, for example, I could break up 20 into 20 times 1. I could break up 60 into 20 times 3. The 20s are what cancel out, which is what leaves me with 1 over 3. This is the magic key. They are factors. They are being multiplied. And because they are being multiplied, the same factor reduces. Now, what this means is if I have x over x plus 1, those x's do not reduce. These do not cancel out. And the reason being is this plus. It's not a factor. So we need to remove from our head this generic, basic, whatever's the same on the top and the bottom reduces. Because that's not necessarily true. It's the same factor on the top and the bottom. That's what reduces. And remember, a factor means multiplication. Now, what about simplifying 10x over 10x? Now, yes, the 10s, they're the same factor, right? Because this is 10 times x, and this is 10 times x. So they're factors. Yes, they're going to reduce. Those x's will also reduce. But if I look at the original, what happens if my x is 0? Well, if I plug in 0, I get 0 over 0. Well, that's undefined. This brings up an issue that we're going to explore further in this chapter. And so what we would have to do is we would have to exclude the possibility of x being 0. Because if I include it, then it gives me an undefined value. But like I said, we just need to be able to recognize it for now, but we're going to explore that idea further. So to find the values that need to be excluded, you set the denominator equal to 0, and you solve for the variable. That's essentially what we need to know. So in this example here, h times k, the h's cancel out. But if I set the denominator equal to 0 and solve, well, h cannot equal 0. So my answer is this. That's what it's simplified to. But my exclusion is going to be h can't equal 0. So for this one, these are factors. So that means the same factor on the top and the bottom will reduce. So the m plus 6's will reduce. So you get 2m minus 5 over 3m plus 1. Nothing else reduces. No, those m's do not reduce because I have a minus here and I have a plus here. It means they're not factors. And because they're not factors, they're not going to reduce. You have to consider this as one whole thing, and you have to consider this as one whole thing. And now my exclusions. So you set each denominator equal to 0. It can't be those values, so you subtract 6. And then you subtract 1 divided by 3. Now you might be thinking to yourself, wait a minute, isn't this very similar to this thing of finding the domain? Yes. The answer is yes. And if we're seeing that, wonderful. Okay, so that 3 minus 2x, those are the same, so those reduce. So I get 1 over 4x minus 1. So now my exclusions, setting each one equal to 0. Can't be that. Add 1. Divide by 4. And then add 2x. Divide by 2. Now sometimes you're going to have to factor it before you reduce it. And so you're going to get x plus 3 and x plus 3 over x plus 3 and x minus 3. So you may have to actually factor it first. Now that they're expressed as multiplication, those x plus 3's reduce, so my answer is going to be x plus 3 over x minus 3. Now my exclusions, setting each of these equal to 0, you can't equal that. So you get x cannot equal negative 3 and x cannot equal positive 3. That's my answer. And then for this one, there's an x in common. And then on the bottom, factor out a 2. There's a 2 in common. The x plus 4's cancel out. Now setting each, so my answer is x over 2, but now my exclusion. So I get that. So that's my answer, and there's my exclusion. So what did we learn today? We learned how to simplify rational expressions, and we talked about exclusions, which are basically the domain of our expression. And then how do we find the excluded values? You set the denominator equal to 0, and then you solve for it. It just can't be those values. This does conclude our lesson. If you have any other questions, please leave them in the comments.